right, do you remember how to take 14 without your calculator into 38,642? Remember how to do that? Yeah. All right, so we're gonna use that same procedure with polynomials. Well, how did we do that? What was your first step? See, remember. Tyler, you remember?
You just find the two numbers that is divisible by, and then one that can be like taking the square root of.
I think we're talking about something different.
No.
Yeah, I'm really not sure where you're going with that in the square root. Maybe. Aubrey?
So you do like, how many times can 14 go into 3? None, so you put a 0. How many times can 14 go into 38? None.
So you go to the next number. So yeah, if you find the first one, what will 14 go into? Doesn't go into 3, will go into 38. Yes. How many times? Is it 2 or 3? 2. And then so we put a 2 up here, right? And then what do we do with that 2? Do you remember?
Leave the 2.
You multiply it by the 14.
Yeah, you multiply 2 times 14, right?
Oh.
What'd you say, Ryan?
I said, oh.
Oh.
I didn't realize we didn't already multiply it.
Oh.
Because I thought to get to the 2 times, like, in, I
Oh.
thought we had multiplied to figure that out.
I don't think that's.
Faith, you remember this?
Yeah, it's
This
just
long
long
division.
So you subtract, you get
Yes.
and then you drop down.
What grade was this?
I remember.
Okay. All right, what do I do here now?
Subtract.
Subtract. And so that's 10, and then, we're done, right?
No.
What? We're done?
No. Bring down to 6, right? 14 goes into 106. Whoa, big number. 7? All right, so there's 70. Okay, 7. So that's 28. Carry a 2. 7 times 1, add. So subtract, and that gives me what, 8? Bring down the 4. 84. Is it 6? 6 times 4 is 24. Okay, it's 84. Wow. 0. Now are we done?
No.
Oh, no, we're not. Bring down the 2. All right, does 14 go into 2?
Yeah. 17 times.
Goes into it 0 times. Now, as you got a little older, then you put a little decimal point, you put some zeros, right? You can do that, but we're not going to that point. What do we do with the 2 now? You first probably did this. You did 27, 16. You probably did remainder 2, right?
Yeah.
But really, what is that? It's 2 over what? Oh, good. It's 2 over in 2 14ths. So it's 2760, and then that 17. All right, we're gonna do the same thing. Obviously, we need a little practice, but we're gonna throw some X's in there and some other things. Now, this we're gonna talk about factors because that's division, and then we're gonna just kind of base it with regular numbers to kind of help with the understanding. So a polynomial, which we'll call d of x, is a factor of a second polynomial if there's a third polynomial, such that this is true. F of x equals d of x times q of x. Your factors are d of x and q of x. Okay, and I'll show you like with this 6 here in a second how that all relates. The main thing is that f of x equals d of x times q of x. All right. Division and multiplication they're kind of intertwined. They're related with one another. You agree 6 equals 3 times 2. Please say yes. Okay. That also means that if I take 6 divided by 3, it has to equal the other factor of 2, because 3 times 2 has to equal 6. If I take 6 divided by 3, it has to equal 2. Or if I take 6 divided by 2, it has to equal 3. That's obvious for you. Polynomials is not so obvious. Will you agree that x squared plus 6x plus 8 we can factor into x plus 4 times x plus 2, correct? X plus 4 times x plus 2 are two factors. So using this analogy over here, that means x squared plus 6x plus 8 divided by x plus 4 has to equal what? X plus 2. Because we know that x plus 2 times x plus 4 has to equal that numerator. Okay, so it's no different than here. Although now you're dealing with polynomials, so it kind of confuses the issue, but it's really the same. Or I could take x squared plus 6x plus 8 divided by x plus 2, and that has to equal what? X plus 4 has to equal your other factor. So these are your two factors. Because they multiply together to give me x squared plus 6x plus 8. You're a little more familiar with 3 times 2 being the factors of 6. All right, now we're going to deal with long division because eventually we're going to deal with that with the polynomials. And then how to graph them is going to come into play here. But we just got to do a little bit of just straight division here just to make sure we get that. All right, we're going to use long division like you did with the 14 into that whatever number we had. Same idea. So the 12m squared plus 7m minus 12, divide that by 4m minus 3. So we take 4m minus 3 divided into 12m squared plus 7m minus 12. The first step is a little bit different. Because let me go backwards. We said, all right, how many times does 14 go into 38, right? Another thing I said, all right, what number times 14 it comes close to 38? Think of it that way. Well, for this one here, say, what number times 3m or what times 3m gives me 12m squared? That's what I want to do. Okay, what times 4m gives me 12m squared? It would be what? 3m. So that's going to be our first term. And I'm going to, not that it's necessary, but typically you should line it up with the same degree. So what is, now take 3m times, you got to take it times the whole thing though. 3m times 4m is 12m squared. 3m times negative 3 is minus 9m. All right, what did we do on long division? Subtract. Now, when you subtract, you got to make sure that you subtract the quantity, which means you put parentheses around it. Okay, that's probably going to be your biggest mistake. Because 12m squared minus 12m squared, 0, I'm good with that, but what do I get here? 16m, right? Because it's 7m minus negative 9, and I get 16m minus, now bring down the next number, bring down the minus 12. And say, what times 4m gives me 16m? That's just what? 4. So that is a positive 4, and if it's a that's going to be your sign, whether it's a plus or minus. And 4 times 4m, hold on. So that gives me 16m minus 12, subtract. And then what does this one actually give me? It actually should give me negative 12 minus negative 12, so it should give me 0. Because that's going to be a plus 12. So I got no remainder. No remainder. So now here's really what it's saying. 12m squared plus 7m minus 12 divided by 4m minus 3 equals 3m plus 4. Correct? And then these two multiplied together have to give me that, right? Got to use the division relationship. All right, so the second one here. 4x cubed minus 4x squared minus 9x plus 5 divided by 2x squared minus x minus 5. You continue to divide until the degree of the remainder is less than the degree of what you're dividing into. In this case, or dividing by, which is 2x squared minus x minus 5. Okay, dividing that into 4x cubed minus 4x squared minus 9x plus 5. What times 2x squared gives me 4x cubed? 2x. So 2x. We'll put that above the negative 9x. So that gives me 4x cubed minus 2x minus 2x squared minus 10x. All right, subtract the whole quantity. Subtract the whole quantity. And make sure that's going to change those signs on the inside. So 4x cubed minus 4x cubed is 0. And then what do I get? I get negative 4 plus 2, so it's negative 2x squared. Negative 9 plus 10 is plus x. And now, bring down your plus 5. All right, what times 2x squared? Now, these are the same degree, right? We go until this degree is smaller than this degree. So these we need to do one more. Because what times 2x squared gives you negative 2x squared? That would be negative 1. Negative 1. And then that gives me minus 2x squared plus x plus 5. All right, now, just be careful when you have something that looks very similar. Make sure they do all add up to 0. In this case, they do. Sometimes there's a tendency to automatically make that the case. All right, so they add up to 0. No remainder. 2x minus 1 is the answer. Okay. All right, I think here we're going to skip the third one. Just go to number 4. You can write it, make it number 3. All right, and just be careful here because what is the top one missing? It's missing a x squared term. Anytime that occurs, we want to hold that place value by putting a 0 in there. So I just want to make sure you get that. So I got x squared plus x minus 3 will divide into, make this 2x to the 4th plus 3x cubed plus 0x squared minus 5x plus 4. Okay. And that just kind of holds that place value so everything lines up when you multiply and then when you do your addition and subtraction. All right, so take what times x squared gives me 2x to the 4th? 2x squared. And that gives me 2x to the 4th plus 2x cubed minus 6x squared. All right, subtract that whole thing. Go to Luca, what do I get when I subtract?
You get x cubed plus 6x squared minus 5x.
Good. So plus 6x squared, bring down your minus 5x. All right, what times x squared gives me x cubed? It'll be an x, so plus x. And that gives me x cubed plus x squared minus 3x. Subtract. All right, what am I left with after I subtract there? Josh, what do I get?
You get 5x squared minus 2x.
5x squared minus 2x, and then I bring down the 4. And now, all right, what times x squared gives me 5x squared? Positive 5. And then that's going to be 5x squared plus 5x minus 15. All right, subtract that whole thing. Ryan, what do I end up with?
Negative 7x
plus 19.
All right, negative 7x plus 19. All right, now at this point, that's the degree of your remainder is x. This is your divisor, x squared. It is smaller. We're done. Okay, that is our what right now? That's your remainder. That is our remainder. Because I can't multiply anything times x squared that is a whole number exponent to get an x. So our answer, so it equals 2x squared plus x plus 5. Now I always make that a plus regardless of what it is. And then, what do we say? Negative 7x plus 19 over what? X squared plus x minus 3. All right, now I know it may not look like it, but you got to understand, and it's very possible. If you multiply those two together, what does it have to give you? Got to give you that numerator. So there, that you would multiply it by that term. It's messy, but it has to work that way. Okay. All right, now that's long division. If you're, don't write this down yet. If you're dividing by something that is a linear term, there is a shortcut. The shortcut is called synthetic division. But it only works if this is like an x plus or minus something. It can't even be 2x. So like we cannot use synthetic division for anything that has like a quadratic. But if it's a linear term, we can. So let's take a look at what's called synthetic division for something on those lines. So go ahead and write down that original. And when you have that, basically, we can just kind of condense the steps into kind of one quick problem. For synthetic division, remember what you do here is you take your coefficients of the numerator. 2, 4, 1, negative 15. Take those coefficients. And in front, typically we make a little box. And if it's x minus 3, you put in a positive 3. And if it was x plus a number, you put in the negative. Okay, so you put in a 3. Always start with a 0, and then what you do is you're going to add vertically. So 2 plus 0 is 2. And now you remember what you do with that 2 and the number in the box? You multiply them together. So 2 times 3 is 6. 4 plus 6 is 10. 10 times 3 is 30. 1 plus 30 is 31. 31 plus 3 is 93. And negative 15 plus 93 is 78. All right, how do I take, you take your bottom row, that becomes your answer. You remember what you do? Okay, the bottom answer is always 1 degree less than what we're dividing into. So if it's x cubed, this is going to be x squared. This last number is always our remainder. So a lot of times we separate it. There we go. Separate by putting a line there. So that's your remainder. So my answer is 2x squared plus 10x plus 31. And then, like I said, I always put a plus, and then it's going to be 78 over x minus 3. Okay. Only works for x plus or minus. Okay, right there. That's why we still need to know long division. But then, like I said, we call this, sometimes it's called the depressed polynomial because it's 1 degree lower. Wait, hold on, I missed one. I always forget about that guy. Okay, you got 3, you got negative 9, you got negative 4, you got 12, divided by x minus 3. So that means this is x minus 3. This becomes a 3 in the front, and then I just have 3, negative 9, negative 4, positive 12. And then go ahead and see what you get there. Make sure you multiply and then add. Multiply and then add. Now, in this case here, so we get 3. 3 times 3 is 9. All right, negative 9 plus 9 obviously is 0. You're not done, so don't just stop and say, oh, I got a 0. Keep going. 0 times 3 is 0. So I do get that second piece, which is negative 4. I get a negative 12 there. That adds up to 0. So now in the end, what does this have to start with? If it's an x cubed, it has to start with x squared. That's an x. That's a constant. Now you don't need to write the x, so it's just going to be 3x squared plus 4. So what do we know? 3x squared plus 4 times x minus 3 has to equal. Okay, has to equal our numerator. Okay, so make sure we know that. 3x cubed minus 9x squared minus 4x plus 12. Okay, for that. All right, let's take a look at one more here. What's the numerator missing? It's missing a term, right? Which one? X to the third. So what do we have to do? Same thing in long division. If it's missing a term, you have to account for it. So we have to put a 0 in that spot. That's the one thing you just got to be careful. Now, since this is x plus 1, put a negative 1. Okay, you can always flip that sign. And so now my coefficients are going to be 3, 0, negative 6, 3, negative 7. And now add, I get 3 times negative 1 is negative 3. Add, I get negative 3 times negative 1 is 3. I get another negative 3. I get a 6. I get a negative 6. All right, so this time it's not a 0, right? Got a remainder. Now my answer, since it's 3x to the fourth, is going to become 3x cubed minus 3x squared minus 3x plus 6. All right, plus negative 13 over x plus 1. Okay. All right, so there you got your long division. Synthetic division we can use. We can use long division with x plus 1. Okay, but this is probably easier. Okay, that's probably easier. All right, page 361 there. We'll have to finish up 3-3 tomorrow, like I said, and then we will